Welcome back to the deep dive. Today we're doing something a little different and plunging into a single piece of hardware. It's the NTI ST-C5V2A-L-1000SP.
Yeah.
And our mission really is to figure out a core engineering puzzle.
Okay.
How do you deliver an ultra-high quality analog video signal? We're talking VGA over, a massive distance using nothing more than standard, cheap networking cable.
Right. So what we're really looking at here is what's called a KVM extender.
KVM, keyboard, video, mouse.
Exactly. And this tech is, well, it's a lifesaver in places like server farms, control rooms, anywhere the computer itself needs to be locked away or just far away.
In another building even.
Could be. But the user still needs perfect instant access. So this system, it just bridges that physical gap. You have a pair of units, one local box at the PC and one remote box out where you are.
Okay, so let's really unpack the scale of this challenge. We're talking about pushing a signal up to a full 1,000 feet.
It's huge.
That's over 3 football fields of distance, using just common CT5, 5E, or 6 cable. In the world of video signals, that feels almost impossible.
It should be.
But here's the paradox right out of the gate. The specs say it can go 1,000 feet, but if you want that maximum resolution, 2048 by 23036, that distance just plummets.
Yeah, down to just 200 feet.
So why does the cable itself limit the resolution so drastically?
Well, that paradox, that's the whole engineering battle, isn't it? They're not just fighting distance, they're fighting signal loss, interference, everything that comes with sending a sensitive analog signal down cheap copper wire.
And VGA is notoriously susceptible to noise.
Extremely. The fact that this simple setup works with, pretty much everything. Windows Server, Linux, even Mac, it shows they really prioritize just making it work universally. But that physical cable, that's always your ceiling for quality and speed.
So how do they do it? How do they beat that noise and degradation to deliver a picture that's crystal clear over such a huge span? That's the real magic trick here.
It all comes down to compensation and relentless, precise tuning. Okay.
The unit automatically adjusts the video quality and, this is critical, the color skew. It's compensating for the different lengths and, frankly, the quality of the CAT cable you're using.
Color skew.
Yeah. And the key spec here is the delay adjustment. They can tune the signal timing with a max delay of 62 nanoseconds.
Which sounds tiny.
It is.
Yeah.
But they can tune it in incredibly fine, 2 nanosecond steps.
2 nanoseconds. That is an absurd level of precision. Why does that microscopic tuning even matter?
Because the red, green, and blue signals in a VGA cable, they don't travel at the exact same speed. They arrive at slightly different times.
Oh, okay. Which causes what, like ghosting or blurry colors?
Exactly. Smears, ghosting, all of it. This 2 nanosecond tuning lets you basically time align those 3 separate color signals perfectly so they hit the remote display at the exact same moment.
And that's what gives you that crystal clear video.
That's it. And once you dial it in with the little push buttons on the remote unit, the settings are just automatically stored. And on top of that signal magic, we should probably mention the build quality. It's a rugged steel construction. It has built-in surge protection.
Right, which you need when you're running cable hundreds of feet.
Yeah, absolutely. And then there are other little technical things like DDC-to-B support.
Which just means the computer and the monitor can talk to each other and automatically figure out the best resolution. It makes the setup much, much simpler.
So what does this all really mean then?
It means you get reliable, high-integrity operation. They back it with a 2-year warranty, and it works across a huge temperature range. It just makes your remote monitor feel like it's sitting right on the desk next to the PC, even if it's 1,000 feet away.
So as we wrap up, let's circle back to that paradox. The high-quality shielded CK6 cable gets you the best resolution, but only for 200 feet. Whereas the cheaper unshielded CT5 cable lets you hit that 1,000-foot mark, but at a lower resolution. The engineering is magnificent, but it can never fully escape the laws of physics.
It can't.
And it really makes you think, doesn't it? How much does that physical medium, that simple, cheap spool of copper wire, how much does it fundamentally limit or enable our long-distance digital world? How often is the underlying physical structure the real bottleneck for your digital experience? Something to think about.